In the third part of this video on graphical user interfaces and event handling, we now see how to associate actions with button clicks. We will examine several different approaches. Some involve inner classes and lambda expressions. Event handling involves writing a method that will be called when an event occurs. We have examined the technique for creating simple GUIs, but the programs did nothing aside from display the GUI. To be useful, programs that contain GUIs must contain event handling. When we add event handling to such programs, events initiate code to be executed. In command line programs, the main method was always where execution began, and from it, a chain of methods could be executed. When we include event handlers, each event handler can initiate the execution of a separate chain of method calls. Although there are many events that can occur, we begin with the two most fundamental kind of events. In this part, we will examine events caused by clicking a button, and in part 4, we will examine events caused by clicking the button on a mouse. Writing an event handler involves implementing a listener interface. In addition, we must make the association between the object that generates the event and the event handling code that listens for it or handles it. The latter step is referred to as registering the event listener. This program is our first example of a program with a GUI that responds to an event. At the top of this program, there is one additional import statement that imports the java.awt.event package, which contains the listener interfaces that we need. Recall that using the wildcard on the import of java.awt is not sufficient. Using a wildcard imports all the classes in the package, but it does not import the classes in the subpackages, like java.awt.event. This program illustrates the simplest approach to event handling. The frame class itself is the listener for the button event. Notice that action 1 extends JFrame, but also implements action listener, which is the interface that a listener for button clicks must implement. Let's scroll down to the section of the constructor where we start adding the GUI components. We add two text fields and two buttons. The text field that is intended for output is made uneditable by calling setEditable and passing in false. That prevents the user from entering any text into that field. The calls to add action listener in the last two statements of the constructor register the frame as the listener for both button clicks. What is passed to that method on both calls is this, which is the object frame that is instantiated in the main method. Failing to register the listener will not cause a compilation error. Instead, the result will be that nothing happens when the buttons are clicked. Because the action1 class implements action listener, it must override, or more precisely implement, the method action performed that is called when either button is pressed. Because this method handles the button click events for both buttons, the first step is to check which button was pressed. That is accomplished by invoking the getSource method on the event object that was passed to the method. The getText method is used to extract the string the user entered in the text field input, and the setText method is used to place the converted string into the text field output. Let's run this program and type something into the text field at the top and then click each of the buttons. Notice the text echoed in the other text field. Depending upon which button we pressed, it converted to either all lowercase characters or all uppercase characters. Although the first version of Java did not include nested classes, they were included in version 1.1 at the same time that Swing and a new event model were introduced. There are two types of nested classes, those that are static and those that are not. Non-static nested classes are usually referred to as inner classes. They are the type of nested classes that are needed with event handling. What distinguishes static nested classes from inner classes is that inner classes can have access to instance variables of the outer class. That capability is what is required of listeners. For that reason, listeners are often defined as objects of inner classes. There are a number of different ways, syntactically, that such listeners can be implemented. The first two approaches that we will consider are by creating named objects of a named class and by creating anonymous objects of an anonymous inner class. The syntax of this second approach looks quite unfamiliar, which is why we will first demonstrate the first approach as an incremental intermediate step. The Action2 class uses an object of a named inner class as the listener. Button Listener is the inner class. Notice that it is nested inside the outer class Action2. In our first version, the class Action1 implemented the Action Listener interface. Now, Button Listener implements that interface, so it contains the method Action Performed. That method is identical to the one in the previous example. Let's scroll down to the constructor of the outer class. The other difference in this version is the last few lines of this constructor. Notice first that we instantiate an object listener of the Button Listener class and pass that object to the Add Action Listener method to register the object listener as the listener for the button click events. This version behaves exactly the same as the previous version, so we will forego running it. Instead, as an experiment, let's try adding static before class Button Listener. Notice that an error was generated on each reference to one of the instance variables of the outer class. Only non-static nested classes, inner classes, are allowed to make such references. Incidentally, this kind of nested class is unique to Java and is not possible in earlier languages like C++. This version uses anonymous objects of anonymous inner classes as listeners. The beginning portion of this one is identical to the first version, aside from the fact that, like the second version, the outer class does not implement Action Listener. So let's scroll down to the section that contains the part that is different. Notice now that there are two Action Performed methods, and they are inside the call to Add Action Listener. With this approach, each button has its own separate listener object, so it is no longer necessary to check which button was clicked. That is one advantage to this approach. The syntax of anonymous inner class objects is a bit unfamiliar and rather awkward, because now a class definition is nested inside a method call. We include this approach because it became the most commonly used approach until some additions in Java 8. But even with those additions, it is an approach that is still needed in certain cases. As before, this version behaves exactly the same as the previous version. so we will forego running it. But what we will do is demonstrate how NetBeans will automatically change anonymous objects of anonymous inner classes to lambda expressions. Notice how the code has been simplified by this transformation. We will discuss lambda expressions next. Before discussing the lambda expressions, it is worthwhile to first explain why such a convoluted syntax, like what we saw in the last example, developed. Unlike most earlier programming languages, Java elected not to permit subprogram parameters. When we register a listener, what we really want to do is pass in the method that should be called back when the event occurs. For that reason, such methods are often referred to as callbacks. Because Java does not permit this ability, it becomes necessary to wrap the callback method in a class, instantiate an object of that class, and pass the object as a parameter. To try to overcome this unfortunate complexity, in Java 8, lambda expressions were introduced. Lambda expressions are actually quite common in functional programming languages that are based on a branch of mathematics known as lambda calculus, which is where they get their name. A lambda expression is really just an anonymous method. Let's look at the syntax of a lambda expression. It contains a list of parameter declarations enclosed in parentheses, followed by an arrow symbol, and then a list of statements enclosed in braces. There are a few simplifications that we omitted. The parameter types can be omitted when they can be inferred. When there is a single parameter and its type is omitted, the parentheses can also be omitted. Finally, when there is a single statement, the braces and the semicolon at the end of the statement can be omitted as well. Lambda expressions can be given names if their type conforms to what is called a functional interface, which is an interface containing only a single method. Recall that NetBeans will automatically change the syntax that uses an anonymous object of an anonymous inner class to one that uses a lambda expression for us if we so desire. We can actually simplify it a bit further. Let's scroll down to the portion of the program that contains the lambda expression. Because there is only one parameter, we can omit the parameter type and the parentheses that surround it. Because the body of the method contains only one statement, we can omit the braces as well. Here is one last possibility. The lambda expressions can be declared to be of type ActionListener, and they can be given names. Let's scroll down to the constructor. Notice that the names of those methods can be passed as parameters. This approach looks most like how subprogram parameters are passed in most earlier languages. All these approaches accomplish the same goal. You can choose the approach that seems simplest to you.